Good morning, class. We are going to start our research and development on understanding the history of measurement. It's not something that just came out of the blue. So if you can imagine the first Neanderthal, he had to measure something and understand where it came from. And there are some wonderful facts on the types of measurements across history, whether it was the Egyptians or the Romans, which were fascinating in how they would develop measurements. And since my background is in surveying and architectural, there's all kinds of things there that we can look at. So, as we look over the history of measurement and how it was controlled and what type of instruments were used, for example, Egyptians actually used the forearms to the fingers to measure. But how accurate would that be?
Especially if you compare mine to yours.
Right, and that brings up a very good thing, because they also were notorious for using the small guy and the big guy. So if they didn't like you, they would actually use a smaller individual for the measurement, okay? Where we call a measurement a foot here, they would call it a pass or pedis. And that was per the foot. That would be under your Romans, where they used how many feet was measured by something. And there again, how accurate could that be?
Again, it varied person to person.
Right.
What do you want to do in my house?
If you take Trace's foot, that's size 2, and compare it to 15.
Right. So over time, we had to become more accurate, because the last thing you want to do is send a spaceship out into the vast and not understand some type of measurement, whether it was a liquid, a gas, the shuttle itself. You had to understand force, energy, mass. So we had to develop over the ages some ideas on how to measure. And for instance, in our program, we use several different types of scales. We're going to use either a metric scale, an engineer scale, or an architect scale, where carpentry is going to use
Tape measures, T-squares, speed squares,
that's right,
protractors.
that's right. And surveyors are going to use tapes. So, now these tapes originally started in chains. And to me, with surveying, that is so fascinating, because a chain would either come in 100 foot, a 66 foot, or a 50 foot. And now the chains are not like the links that we see today. They were straight and had the curve on the piece, so it was along and curved at each end, and there were 100 of them, depending on the type of tape.
Yeah, I sit here thinking about a logging chain. I'm like, wouldn't that be too heavy for a surveying company?
No, they actually, and as it evolved, then they went to your round links. Okay, but what happens in the difference in temperature?
Okay, Spanish.
Spanish, shrink.
Correct, that's right. Or add an additional element to that,
Becomes brittle,
Wear.
rusted.
these would wear. So as they wear, your chains become longer. So that would affect a land survey. And you know, this whole country was divided up into sections, townships, and ranges. And they would have to go out and measure them with the chains. So if the chain wasn't right, that section could be longer or shorter, depending on what it was. So had you ever thought about a surveyor using a chain before?
No, it's always something new for me.
Okay. So now you've been at least introduced. I wish I had a chain for you, because it would show you what to do. You know, and what it felt like, how heavy it was to drag that chain. So I mean, it was a crew across this country dragging that chain. So when we look at the drawings that we're producing in here, and Anthony, I know that you've already had to do a quality control with the maps in the back. So what is the importance of a scale?
Make sure all your pieces are built, produced, and assembled the same size, the right way, repetitively.
Because if the sheet is not technically correct,
Your parts won't be right.
that's right. So, you know, and knowing that you can draw it correctly, that's a big thing. You don't just sketch. This is not sketch, this is technically correct. That's why you're in here. This is your skill. I can draw something technically correct. I can print it to scale. I can quality control by checking it with a scale. These scales have lots of different measurements on them. So whether this end is a 1/2 inch, the opposite end will be 1 inch. So they have a dual role. But do you notice anything unique about this shape on the end? What do you see, Malachi?
Kind of like a stars, or like a.
How about in the automobile industry? What does that shape look like?
Mitsubishi.
Okay, that is a symbol for precision. So now when you look at it, you'll look at it differently because that symbol represents precision.
Mitsubishi ruler.
So the very same item that you're using to check a drawing scale. Now, on a drawing, it can be printed not to scale, and it'll usually have the initials NTS, which represents not to scale. Would you want to use that in the film?
No.
No. We could use it as an illustration because all we're going to do is speak about it, show the image of it. But when we went to work to build the house, make a car part, make a machine part, we've got to have it accurate. And I can't stress the accuracy part enough.
Found an image of the Gunther's chain at your.
The Gunther's chain. Yes. On your computer, bring up Gunther, Gunther chain. And you'll see this odd looking chain. And they're really in the historical items. They're not something that's produced anymore.
I think it's an interesting concept though. But at the same time, it's also got a lot of room for failure. Like I said, wear, tear, temperature expansion and shrinking.
It doesn't, does it? But it had to be light enough to be carried across the country.
Yeah, it's a lot better than logging chain.
But then they did change over to chains. They thought these are sturdier, they're thicker, they're heavier, they'll take a lot more wear and tear. But it didn't matter. Environmental impact on them, heat, cold, wear was an issue. So that we we needed to get used to on what we're doing, what we were using, what you're doing with them. You know, typical questions of surveyors, they breathe and eat the measurement, how many feet are in a mile. 5280. You are correct. I am proud of you. So 5,280 feet.
Honestly, did not remember that number.
Yeah, that's in a mile. So can you imagine applying the Egyptian measurement and toe to heel finding 5,280 feet?
A lot of walking.
We don't have to do that. Now, we don't even have to use a chain. They have what they call a total station. So they put a marker, the laser.
It's essentially a rangefinder on steroids, isn't it?
It is a small satellite that comes in. I mean, you're carrying it like a backpack, and it comes in. And you put a marker somewhere, it goes straight to it. It reads the slope. It reads, you know, the temperature. Everything comes into surveying your temperature. You have to write down in your log, it was sunny, it was cloudy. All that comes into surveying as a part of making the survey. Now, what I've got right here, and I want you to come look, I have acquired some old antique surveying equipment. This is called a transit. This is one of the earliest pieces of equipment. And it is very unique. I'm very proud of it. It was my father's. It's what he used when he surveyed. And he had to use a plumb bob. That comes into your measurement because you want to make sure your instrument is horizontal, vertical. Everything had to come in as when you were setting it up. And you'll see this one was a few years later. Now that this would be considered an antique. So we don't even use those anymore. So what kind of questions do you have about measurements? What do you find fascinating on the types? I mean, even a thumb was used as a measurement. And everybody's thumb is different. I don't think that my thumb and your thumb are the same.
No, it ain't quite the same.
So, no. So everything would not be correct. I mean, everybody would be
Yeah,
wrong.
different foot sizes, hand sizes, arm sizes.
So
There's even one that was the digitus, where they were using the finger digits.
Yes, yes. So your finger, I'm glad that you saw that in the text. Digitus. So my digitus and your digitus are not going to be the same. So we have to take into account.
And then you have people like me that have broken my hand so much that I can't even straighten my fingers anymore.
That definitely makes a difference.
So we have seen a various type of measurements, whether it was land, whether it was, can you imagine cubits? How they did cubits? It's just fascinating. Measurement, the history of surveying, that to me is fascinating, because when you go back, where did it start from? It had to start somewhere. So when you start looking at Rome and Egyptians, you know, they had the science behind it. They really were accurate. Look at the pyramids. I mean, they had to be very accurate, or
Aliens.
what would have happened? It all fall down. So, and now that's another thing. Looking in the pyramids, with measurements, they had, you know, certain secret passages in there, and most of them were used for the function of water pressure, because they would drive water. We've seen all the old movies where all the slaves are pulling up these heavy stones. It couldn't be done, not in the time period. They had to use water pressure.
Mhm.
And around those pyramids was a lake at one time.
I never knew, I didn't know that part.
And
I knew
as
they had
it
like
dried up-
aqueducts and the, like built into the pyramids to move the stones. but
Yeah.
There were lakes.
The Sphinx head actually sits where the lake was.
Hmm.
Knowing your history, knowing the history of measurement, understanding where it came from and how we have developed to where now it is, you hear nanoseconds and, you know, the smallest 1,000th, 1,000,000th of an inch. Or you can look at our technology and tell that they have measured that down because of the equipment within a computer is so small. So they had to measure to make everything fit within our box.
Another
Where-
example of that would be like firearms.
Mhm.
When you got the champers in the chambers, your spring length, your barrel length, everything's gotta be perfect.
Right, and if it's not, it doesn't work. So, if measurement's not right, the land survey's not right, the instrument is not right, the house is not right. So we have to pay attention to the accuracy of measurement. And I wanted you to see a history, you know, tools that we use now, tools that they used then. Again, do you have any questions? What do you find fascinating about measurements?
The fact that the metric system has never put anybody on the moon.
I hadn't thought about that, but who knows? It may come and it may come. You know? Had you ever thought about measurement like that? I mean, you just say, I drive 10 miles to school. But 10 miles is how many feet?
Come on, math guy.
52,800 feet, right?
Yeah, I guess that makes sense.
All right. Okay. I would like for you, in your own time, to look up some more information about measurements, and I'd like you to come back and share some interesting facts that you find. All right? Thank you. I'll let you get back to work.
You want me to put them back up?
Yes, if you don't mind.
Grab one.
I wouldn't trust that strap too
Yeah.
much. Yeah, this one's missing the latch, right?
What, yes,
Okay.
yeah.
What score do you want to make
I think they're 72.
before we start the review?
I would like for you to make about an 80 to start.
That is just 1.1.
Okay, let me give you a review on this. Send me an email,
Not
Tom.
on there, on the Autodesk.
Oh, okay.
I haven't tried yours.
Okay, that's